Step foot into the fascinating realm of lunar exploration and uncover the secrets of humanity's most extraordinary achievements in space. Join us on an epic journey as we delve into the rich history and untold stories of mankind's quest to explore the moon. From the Apollo missions to the latest breakthroughs in lunar science, discover the remarkable significance of the moon and its impact on our past, present, and future. Get ready to experience a breathtaking adventure that will leave you inspired, informed, and in awe of the wonders of our universe. The moon has held our imaginations for millennia, yet it is only in modern times that we have visited this body, first with robotic machines and then with astronauts. Exploration of the moon has taught us much about the evolution of the solar system and ourselves. We've known for centuries about the effects on tides and biological cycles from a waxing and waning moon. But it took space-age exploration to show us how the moon is connected to human existence on a very fundamental level. The space age arrives, robots to the moon. With the shocking launch of Sputnik 1 in October 1957, the moon changed from a distant silver disk in the sky to a real place, a probable destination for probes and people. The Soviets struck first, flying Luna 1 by the moon in January 1959. They followed this success with several other robotic probes, culminating later the same year with Luna 3, which photographed the far side of the moon, never visible from Earth. From these early, poor-quality images, we discovered that the far side has surprisingly little of the dark, smooth mare plains that cover about a third of the near side. Other surprises would soon follow. In response to the 1961 flight of Soviet cosmonaut Yuri Gagarin, President John F. Kennedy committed the United States to land a man on the moon by the end of the decade. Humans on the moon. At the time, NASA was racing to fulfill a presidential promise. In 1961, President John F. Kennedy committed the United States to land a person on the moon before the decade was complete. The Apollo program, by far the most expensive spaceflight endeavor in history, kicked off that year, and by the time it ended in 1972, 9 missions and 24 astronauts had orbited or landed on the moon. Perhaps the most famous of those, Apollo 11, marked the first time humans had stepped on another world. On July 20, 1969, Neil Armstrong and Edwin Buzz Aldrin touched down in the Sea of Tranquility in the Lunar Lander Eagle, while astronaut Michael Collins orbited the moon in the Command Module Columbia. Armstrong, who pressed the first boot prints into the moon's surface, famously said, "That's one small step for a man, one giant leap for mankind." The pair stayed on the moon's surface for 21 hours and 36 minutes before rendezvousing with Collins and heading back to Earth. Each mission after Apollo 11 set new milestones in space travel and lunar exploration. 4 months after the first humans reached the moon, Apollo 12 touched down, achieving a much more precise landing on the moon. Apollo 13 narrowly avoided a near disaster when onboard oxygen tanks exploded in April 1970, forcing the crew to abort a planned moon landing. All 3 survived. During the third lunar landing in January 1971, Apollo 14, Commander Alan Shepard set a new record for the farthest distance traveled on the moon, 9,000 feet. He even lobbed a few golf balls into a nearby crater with a makeshift 6-iron. Apollo 15, launched in July 1971, was the first of 3 missions capable of a longer stay on the moon. In the course of 3 days spent on the lunar surface, achievements included collecting hundreds of pounds of lunar samples and traveling more than 17 miles in the first piloted moon buggy. The Soviet Union had sent a remotely controlled rover to the moon, Lunar 1, in 1970. Apollo 16 and Apollo 17 in 1972 were the 2 most recent crewed missions to the moon, and Russia's Luna 24 crewless spacecraft in 1976 was the last to land until the following century. Samples collected during these lunar explorations produced huge amounts of knowledge about the geology and formation of the Earth's moon. See a timeline of the space race and its modern-day version in private spaceflight. After the dramatic accomplishments of the 1960s and 1970s, the major space agencies turned their attention elsewhere for several decades. So far, only 12 humans, all Americans and all men, have set foot on the moon. Moon's curiosity builds again. It wasn't until 1994 that the moon came back into focus for the United States, with a joint mission between NASA and the Strategic Defense Initiative Organization. The Clementine spacecraft mapped the moon's surface in wavelengths other than visible light, from ultraviolet to infrared. Hiding in the more than 1.8 million digital photos it captured were hints of ice in some of the moon's craters. In 1999, the Lunar Prospector orbited the moon, confirming Clementine's discovery of ice at the lunar poles, a resource that could be crucial for any long-term lunar settlement. The mission's end was spectacular. Prospector slammed into the moon, intending to create a plume that could be studied for evidence of water ice, but none was observed. 10 years later, NASA's LCROSS spacecraft repeated this experiment and found evidence of water in a shadowed region near the moon's south pole. Since 2009, the Lunar Reconnaissance Orbiter has taken high-resolution maps of the lunar surface. Between 2011 and 2012, it was joined in orbit by NASA's twin URAL probes, named Ebb and Flow, which mapped the moon's gravitational field before intentionally crashing into a region near the lunar North Pole. The robots return, Clementine and Lunar Prospector. In the 1990s, two small robotic missions were sent to the moon. For 71 days in 1994, the joint NASA Strategic Defense Initiative Organization Clementine mission orbited the moon, testing sensors developed for space-based missile defense, as well as mapping the color and shape of the moon. From Clementine, we documented the enormous South Pole Aitken Impact Basin, a hole in the moon 616 miles across and over 8 miles deep. This basin is so large, it may have excavated the entire crust down to the mantle. The color data from Clementine, combined with Apollo sample information, allows us to map regional compositions, creating the first true rock map of the moon. Finally, Clementine gave us a tantalizing hint that permanently dark areas near the south pole of the moon may contain frozen water deposited over millions of years by impacting comets. The future and significance of lunar exploration. Now we are preparing for humanity's return to the moon. Over the next couple of years, at least 4 international robotic missions will orbit the moon, making global maps of unsurpassed quality. We will soft land on the moon, particularly the mysterious polar regions, to map the surface, examine the volatile deposits, and characterize the unusual environment there. Ultimately, people will return to the moon. The goals of lunar return this time are not to prove that we can do it, as Apollo did, but to learn how to use the moon to support a new and growing spacefaring capability. On the moon, we will learn the skills and develop the technologies needed to live and work in another world. We will use this knowledge and technology to open the solar system for human exploration. The story of the moon's history and processes is interesting in its own right, but it has also subtly shifted perspectives on our origins. One of the most significant discoveries of the 1980s was the giant impact 65 million years ago in Mexico that led to the extinction of the dinosaurs, allowing the subsequent rise of mammals. This discovery, made possible by recognizing and interpreting the telltale chemical and physical signs of hypervelocity impact, came directly from the study of impact rocks and landforms stimulated by Apollo. Scientists now think that impacts are responsible for many, if not most, extinction events in the history of life on Earth. The moon retains this record, and we will read it in detail upon our return. By going to the moon, we continue to obtain new insights into how the universe works and our origins. Lunar exploration revolutionized the understanding of the collision of solid bodies. This process, previously thought to be bizarre and unusual, is now viewed as fundamental to the planetary origin and evolution, an unexpected connection. By returning to the moon, we anticipate learning even more about our past and, equally importantly, obtaining a glimpse into our future. As we conclude this journey through the history and significance of lunar exploration with CTA, we can only marvel at the audacity, perseverance, and sheer human spirit that drove us to reach the moon and beyond. From the first steps of Neil Armstrong to the recent discoveries of water molecules and ice sheets, we have learned more about our nearest celestial neighbor than ever before and paved the way for future generations to follow. The quest to understand the moon and the cosmos is far from over, and with each new mission and discovery, we are reminded of the power of science, innovation, and exploration to inspire and unite us as a species. Don't forget to subscribe to our channel, or you will miss our informative videos.